Dear learners, welcome to the course Disaster Management Strategies. As you know, Module 18 entitled Causes, Effects and Mitigation Measures of Drought, Tsunami, Volcanic Eruptions and Industrial Disasters consists of 3 units. The third and final unit of Module 18 is Unit 39, Industrial Disaster and Disaster Risk Reductions. Today, we will explore this unit together. I am Utpal Deka, your course coordinator from Krishnakanta Hendrik State Open University. I am excited to have you with me on this journey. Let's get started. In Unit 37, we studied drought, a slow onset hazard that erodes livelihoods and ecosystem over months or years. In Unit 38, we examine tsunami and volcanic eruptions, sudden high impact geophysical events that can devastate coastal and inland regions with little warnings. Unit 39 now turns to industrial disasters, human-made emergencies caused by failures in industrial processes, chemical handling, or infrastructure. Unlike natural hazard, industrial disasters often originate from technological, operational, or human errors, but their consequences can be just as catastrophic, affecting human health, the environment, and society for decades. India has experienced several major industrial incidents, making this topic critical for understanding modern disaster risk reduction. In this unit, we will cover definition and nature of industrial disasters, major causes of industrial disasters in India, devastating primary, secondary, and long-term effects of industrial disasters, practical and evidence-based mitigation measures, including structural, non-structural, and community-based approaches, real-world examples and lessons from major incidents. By the end of this unit, you will understand why industrial disasters are often preventable and how strict regulations, safety protocols, emergency planning, and community awareness can significantly reduce their risk and impact in India's rapidly industrializing regions. First, we start with definition of industrial disasters. An industrial disaster is a sudden or prolonged incident caused by activities in manufacturing, chemical processing, storage, transportations, or energy production facilities. It results in widespread harm to human life, health, property, or the environment. These disasters typically involve hazardous substances, for example, toxic chemicals, radioactive materials, flammable gases or liquids, explosions, major fires, toxic gas releases, structural collapse, or other failures in industrial operations. Nature of industrial disasters. Industrial disasters are entirely human-made emergencies that arise from failures in industrial processes or systems. Unlike natural hazards like floods, earthquakes, tsunamis, etc., they are not caused by natural forces but by preventable factors such as technological or equipment failures, human error or negligence, poor maintenance of machinery and safety systems, inadequate safety protocols or training, violations of safety regulations. Industrial disasters can strike suddenly, for example, explosions, fires, etc., or develop gradually, for example, slow toxic leaks, chronic radiation exposure. Their impacts are often widespread and long lasting, contaminating air, soil, water, and food chains for decades. And they can affect large populations far beyond the factory site. Most importantly, industrial disasters are almost always preventable through proper designs, regular maintenance, strict safety standards, effective training, and strong regulatory enforcement. Now we will discuss key characteristics of industrial disasters. Industrial disasters have several distinct features that set them apart from natural hazards. The main characteristics are discussed below. First, human-made origin. These disasters are not caused by natural forces but by preventable mistakes or systematic weaknesses in industrial operations such as faulty equipment, operator negligence, lack of safety training, or non-compliance with safety standards. Sudden or gradual onset. Some industrial disasters strike instantly and with extreme violence. For example, explosions, major fires, or sudden toxic gas releases. Others develop gradually and silently over time. For example, slow toxic leaks, long-term radiation exposure, or chronic chemical contaminations, making them harder to detect until severe health or environmental damage has already occurred. Widespread and long-lasting impact. Toxic, flammable, or radioactive releases can spread through air, soil, groundwater, and rivers, contaminating large areas far beyond the factory site. The efforts often persist for decades, poisoned soil and water, increased cancer rates, birth defects, and damaged ecosystem, affecting thousands or even millions of people long after the initial event. Preventable nature. Almost all industrial disasters are avoidable. They result from human decisions or failures that can be eliminated through proper plant design, regular maintenance, strict safety protocols, comprehensive training, regular audits, and strong regulatory enforcement. Industrial disasters in India. India, as one of the fastest growing industrial economies, has experienced several major industrial incidents that highlight the risk of rapid industrializations near densely populated areas. Notable examples include Bhopal gas tragedy of 1984, Jaipur oil depot fire of 2008, Phokjan oil well blowout and fire 2020 of Assam. These events show that industrial disaster pose a serious and growing threat in India due to expanding industries, dense population clusters near factories, and sometimes inadequate safety enforcement. Now we will discuss causes of industrial disasters in India. Industrial disasters in India results from a combination of technical failures, human errors, and systematic weaknesses. These incidents are almost always preventable and stem from avoidable shortcomings in design, operations, maintenance, or regulation. The main causes are grouped below. Let us first discuss technical and operational causes. Industrial disasters often begin with technical or operational failure inside the facility itself. These failures are usually preventable and stem from issues related to equipment, processes, or the handling of hazardous materials. They frequently serve as the immediate trigger for major incidents. The main causes include equipment failure or poor maintenance, corrosion of pipes and tanks, faulty valves, worn out pipelines, or malfunctioning safety devices such as pressure relief valves, alarms, or interlocks often lead to leaks, explosions, or fires. Poor or irregular maintenance is a very common factor, especially in older or aging industrial plants. Process safety failures. Over-pressurization of vessels, runaway chemical reactions, inadequate cooling systems, or failure to control temperature and pressure can cause catastrophic releases of hazardous substances. The absence or bypass of safety interlocks and emergency shutdown systems makes these situations far more dangerous. Improper storage and handling of hazardous materials. Storing toxic, flammable, or radioactive substances in unsafe ways, such as overcrowding tanks, inadequate secondary containment, or poor leveling, greatly increases the risk of spills, leaks, fires, or explosions. Next, we will discuss human and organizational causes. Human and organizational factors play a major role in triggering industrial disasters. These causes are almost always preventable and stem from errors, negligence, or weaknesses in how people and organizations manage safety. The main human and organizational causes include Human errors. Mistake by operators, lack of proper training, fatigue, negligence during operations or maintenance, or deliberate bypass of safety protocols, for example, disabling alarms, frequently trigger disasters. Human errors is one of the most common immediate causes of industrial disasters. Inadequate safety management, poor risk assessment, absence of emergency response plans, insufficient regular safety audits, weak safety culture within the organizations, and failure to learn from near misses or past incidents contribute significantly to major accidents. Regulatory and enforcement gaps, weak implementation of safety laws, corruptions, insufficient or ineffective inspections by regulatory authorities, and lack of strict penalties allow hazardous conditions to continue unchecked in many industrial units. Now we will discuss external and environmental causes. External and environmental factors can act as triggers or amplifiers for industrial disasters, even though they are not the primary origin of the event. These causes involve outside forces or conditions that damage facilities or existing hazards. The main external and environmental causes include natural hazards as triggers. Natural events such as earthquakes, floods, cyclones, lightning strikes, or extreme weather can severely damage industrial facilities. For example, an earthquake can rupture pipelines, topple storage tanks, or damage safety systems, leading to leaks, fires, or explosions. Flood can submerge chemical stores or electric equipment, causing spills or short circuits. Lightning strikes can ignite flammable materials or damage control systems. This secondary disaster, for example, chemical spills after flood or fires after earthquakes, often turn a natural hazard into a major industrial emergency. Sabotage or terrorism. Deliberate act by individual groups or terrorists can target industrial facilities to cause intentional releases, explosions, or fires. Although rare in India, sabotage or terrorism remains a potential threat to high-risk sites, for example, chemical plants, refineries, or nuclear facilities. Such act can lead to catastrophic toxic releases or widespread disruption. While technical failures and human errors are often the immediate triggers, most major industrial disasters in India, such as the 1984 Bhopal gas tragedy, result from deeper systematic issues like poor safety culture, inadequate regulatory enforcement, insufficient safety audits, and failure to learn from past incidents. Industrial disasters are almost entirely preventable through strict adherence to safety standards, regular maintenance, comprehensive training, thorough risk assessment, and strong regulatory oversight. In a rapidly industrializing country like India, where many factories are located near densely populated areas, addressing these causes is critical to protect human lives, public health, and the environment from future tragedies. Now we will discuss effects of industrial disasters. Industrial disasters cause immediate harm as well as long-lasting consequences that affect human health, the environment, the economy, and society. Their impacts can be grouped into primary effects, that is direct damage from the incident, secondary effects, that is consequences triggered by the event, and long-term effects, that is ongoing problems that persist for years or decades. Let us first discuss primary effects. Primary effects are the immediate and direct consequences caused by the industrial disaster itself. These occurs at the moment of the incident and create an instant threat to life, health, and property. The main primary effects include immediate deaths and serious injuries, explosions, major fires, toxic gas inhalation, Chemical burns or structural collapses kill or severely injures workers and nearby individuals within seconds or minutes of the event. Sudden releases of hazardous substances, toxic gases, flammable liquids, radioactive materials, or other dangerous chemicals are released abruptly into the air, water, or soil, posing an immediate danger to human life, health, and the surrounding environment. Destruction of infrastructure. Factory buildings, equipment, storage tanks, pipelines, control rooms, and nearby structure are destroyed or severely damaged by the force of the explosion. Intense heat from fires or corrosive effects of released chemicals. Primary effects happen almost instantly and are responsible for the initial loss of life, injuries, and physical destruction at the site. In India, events like the 1984 Bhopal gas tragedy showed how a sudden toxic gas release can cause thousands of immediate deaths and injuries within hours. Because these effects are rapid and violent, prevention through robust safety system, for example, pressure relief valves, containment, fire suppressions, and quick emergency responses like on-site alarms, evacuation drills is critical to limit the scale of harm during the first moments of an industrial disaster. Now we will discuss secondary effects. These effects emerge as direct consequences of the initial industrial incident and often cause additional widespread harm beyond the immediate site. They extend the disaster's impact to people, communities, and economy. The main secondary effects include acute health impacts. People exposed to toxic chemicals, gases, radiations, or fire suffer immediate medical emergencies, including poisoning, respiratory failure, severe burns, blindness, organ damages, and other life-threatening conditions. These acute health crises require urgent medical intervention and can overwhelm local hospitals. Environmental contamination. Toxic substances spread rapidly through air, soil, groundwater, rivers, and food chains, polluting large areas far beyond the factory. As for example, the 1984 Bhopal gas tragedy released methyl isocyanate, contaminating soil and water sources and making them unsafe for drinking, irrigation, and agriculture for decades. Evacuations and displacement. Thousands of nearby residents are forced to flee their homes due to unsafe living conditions from toxic fumes, contaminated water, or structural risk. Displacement can be temporary, days to months, or permanent, leading to long-term relocations and loss of community ties. Economic loss. Factories shut down for safety reason or cleanup, causing immediate job losses. Medical treatment costs rise sharply. Compensation claims flood in, and industrial output drops significantly, affecting local business, supply chains, and regional economies. Secondary effects turn an industrial accident into a broader crisis by spreading harm to health, environment, homes, and livelihoods. In India, events the Bhopal gas tragedy 1984 showed how a single toxic release can contaminate land and water for generations, displacement communities, and create massive economic burdens. Because secondary effects are triggered by the primary incidents, effective mitigations requires rapid emergency response, for example, evacuations, decontamination, containment of spills, and long-term support like medical care, compensation, environmental cleanup, etc., to limit the disaster's wide and lasting consequences. Now we will discuss long-term effects. The impacts of such disasters often persist for decades or even across generations, shaping health, environment, society, and economies long after the initial event. The main long-term effects include chronic health issues. Population exposed to hazardous substances or radiation experiences elevated risks of serious conditions, including various cancers such as thyroid or leukemia in notable cases. Congenital anomalies and birth defects, fertility and reproductive problems, persistent respiratory illnesses, neurological disorders, and other chronic diseases that may emerge or worsen years later. Environmental contaminations and degradations. Long-lasting pollution of soil, groundwater, rivers, and ecosystems severely limits agricultural viability, disrupts food chains, diminishes biodiversity, and renders large areas uninhabitable or unproductive for extended periods, sometimes requiring generations to achieve meaningful recovery. Psychological and social consequences. Survivors and their communities frequently grapple with enduring mental health challenges such as chronic depressions, post-traumatic stress disorder, complicated grief, and deep-seated distrust of corporations, governments, or regulatory bodies. Additional burdens include social stigma directed at affected individuals, family disruptions or separations due to displacement, eroded community cohesion, and intergenerational trauma. Economic and legal repercussions. Affected regions, government, and responsible parties faced prolonged financial pressures from ongoing victim compensation programs, extended litigations, enormously costly remediations and decontamination efforts, diminished property values, reduced economic investment and tourism, and broader reputational damage that hampers regional development for years or decades. Ultimately, the Bhopal disaster and similar events illustrate that industrial accidents are rarely isolated incidents. Their long-term ramifications can transform a momentary catastrophe into a multi-generational crisis. Preventing such outcomes demands not only robust pre-event mitigations but also committed, sustained post-disaster strategies, including comprehensive medical surveillance, environmental restorations, psychological support, equitable compensation, and accountability to break the cycle of suffering and foster true recovery and resilience in industrialized regions. Now we will study real world examples of industrial disasters. First, Bhopal gas tragedy of 1984. World's worst industrial disaster. On December 2 to 3, 1984, 45 tons of toxic methyl isocyanate, that is MIC, leaked from Union Carbine's pesticide plant in Bhopal, exposing more than 5 lakhs people. Causes: water ingress triggered runaway reactions, faulty valves, disabled safety systems like refrigerations, scrubbers, poor maintenance, understaffing, cost cutting, late regulations, etc. Immediate impact: from 3,000 to 10,000 deaths in days or weeks. Mass injuries including blindness, pulmonary edema. Long-term impacts: 22,000 total deaths. Chronic illnesses including respiratory cancer, birth defects in greater than 5 lakhs people. Persistent soil and groundwater contaminations, ongoing justice struggles. Next, we will discuss Phokjan oil well blowout and fire 2020 Assam. Phokjan oil well blowout and fire 2020 Assam is a major onshore incident by Oil India Limited in Tinsukia district near sensitive ecosystems. Blowout on May 27, 2020 during workover ignited June 9 into massive jet fire, greater than 100-meter flames and greater than 1000 degrees centigrade. Burn 173 days until capped November 15, 2020. Causes: pressure control failure, procedural or equipment lapses, safety compliance issues, late environmental clearance as per the National Green Tribunal, immediate impacts, 3 deaths, injuries, evacuations of thousands, and local destructions. Long-term impacts: severe biodiversity loss, 55% decline in affected Dibru-Sokhwa area and Magori Motapung areas. Wetland forest damages, approximately 1,632 hectares. Pollution such as thermal, noise, soil and water, 10 plus year recovery needed, ongoing compensation demands, etc. Mitigation measures for industrial disaster risk reductions. India's approach to mitigating industrial disasters combines structural, that is engineering based, non-structural, that is policy, planning and regulatory oriented, and integrated community oriented measures. The primary goal is to prevent incidents where feasible and substantially minimize their impact when they occur, thereby protecting lives, public health, the environment, the economic assets in the context of rapid industrial growth. Now we will discuss non-structural measures. First, regulatory framework and strict enforcement. Key legislation include the Factories Act 1948 with amendments, the Environment Protection Act 1986, the Manufacturing, Storage and Import of Hazardous Chemicals Rules 1989 as amended, and the Major Accident Hazards Control Rules 1997. These mandates safety audits, risk assessment, emergency planning and compliance reporting. The National Disaster Management Authority issues hazard-specific guidelines for chemicals, petrochemical and other high-risk sectors aligned with the National Disaster Management Plan, updated periodically to maintain coherence with global frameworks such as the Sendai Framework. Hazard identification and risk assessment. Industries must conduct regular studies including hazard and operability analysis, failure, mood and effect analysis, process hazard assessment and comprehensive safety audits. These processes identify potential risk, facilitate the implementation of layered controls and enable continuous risk monitoring. Training, capacity building and safety culture. Mandatory training programs addresses the safety handling of hazardous materials, emergency procedures, proper use of personal protective equipment, that is PPE, and incidents reporting. Efforts to foster a proactive safety culture encourage near miss reporting, continuous improvement, and worker involvement in safety related decisions. Public awareness and community right to know. Residents near industrial sites receive information on potential hazards, early warning signals, evacuations protocols, and chemical inventories through targeted campaigns, public disclosures, and community engagement initiatives. Now we will discuss structural measures. Inherent safety principles in designs. Industries prioritize safer alternatives by substituting hazardous substances with less dangerous ones, minimizing inventories of toxic or inflammable materials, intensifying processes to reduce volumes, and simplifying operations to lower inherent risk. Engineered safety system and control. Facilities install essential safeguards such as pressure relief devices, automatic emergency shutdown system, spill containment, burns, advanced fire suppressions and detection systems including gas, vapor detectors, and robust secondary containment for storage tanks, for example, double walled designs. Safe location and buffer zoning. High hazard industries are sited away from densely populated areas with adequate separation distance and buffer zone to limit off-site impacts from releases, fires, or explosions. Now we will discuss integrated and community-oriented approaches. On-site and off-site emergency planning. Industries prepare detailed on-site emergency plans for internal containment and response while coordinating with district and local authorities on off-site plans that address evacuations, medical trains, decontamination, and public safety measures. Regular mock drills and multi-stakeholder capacity building. Periodic simulation exercises involve industries, local administrations, emergency services like fire, police, medical, etc., and hospitals to validate and refine plans. Community-based programs such as the Apada Mitra initiatives develop volunteer networks for first response and awareness. Medical preparedness, rehabilitation, and long-term support. Authorities pre-position antidotes, decontamination equipments, medical stockpiles, and specialized facilities. Protocol ensures immediate medical response, long-term health surveillance for affected populations, and mechanisms for compensation and rehabilitation. Most industrial disasters arise from preventable factors such as design flaw, inadequate maintenance, human error, weak safety protocols, and insufficient emergency readiness, as illustrated by Bhopal gas tragedy and other incidents worldwide, including Carnival 1986. In India's context of accelerating industrial expansion and increased chemical uses, rigorous enforcement of safety regulations, frequent independent audits, widespread awareness, technology integration, and multi-agency coordinations remain essential. Effective implementation of these layered mitigation strategies can largely prevent disasters or significantly reduce their human, environmental, and economic consequences, thereby promoting resilient and sustainable industrial development. Dear learners, in this unit we explored industrial disaster as entirely human-made events triggered by breakdown in industrial system, often involving hazardous materials. We identified their primary causes, technical malfunctionings, human errors, inadequate safety management, and gaps in regulation. We also examined their far-reaching consequences, such as immediate and chronic health impacts, from acute poisoning to increased cancer risk, severe environmental contaminations, and profound social disruptions like displacement, psychological trauma, and economic loss. Importantly, we reviewed proven strategies for prevention and mitigations, including robust regulations, thorough risk assessment, effective engineering controls, comprehensive emergency planning, ongoing workers training, and strong community awareness programs. Unlike natural hazards, industrial disasters are fundamentally preventable as they stem from avoidable failures that we have the knowledge and tools to address. As informed citizens and future advocates, each of you now carries an important responsibility to champion stronger safety standards, support consistent enforcement of regulations, and raise awareness in communities living near industrial zones. Thank you for completing Unit 39 and Module 18. You have now studied a full range of major hazards including flood, earthquakes, landslide, drought, tsunamis, volcanic eruptions, and industrial disasters lastly. Use this knowledge to help build safer, more resilient communities wherever you are. Stay vigilant, stay prepared, stay resilient. Thank you.